So we've talked about differentiation a little bit with kind of some basic differentiation rules, but there are more ways to differentiate. One of those ways is using what's called the product and quotient rules. So we're going to first start with the product rule. The product rule states the derivative of f of x times g of x is equal to f of x times the derivative of g of x plus g of x times the derivative of f of x. So it's pretty straightforward, pretty simple, but let's actually put this into action here. So for number 1, our first example, we have y is equal to x squared plus 3x minus 1 times 2x squared minus 5. Well, to find our derivative, y prime is going to be equal to, and I like to think of this as the first times the derivative of the second plus the second times the derivative of the first. So our first is just going to be x squared plus 3x minus 1 times, and now I need to take the derivative of this right here. Well, I know from my basic differentiation rules that this derivative is just going to be 4x plus, and I take the second, so I have 2x squared minus 5 times the derivative of the first I know is just going to be 2x plus 3. And I can kind of multiply through here and simplify a little bit. It looks like I'm going to have 4x cubed plus 12x squared minus 4x. And then here I'm going to have 4x cubed plus 6x squared minus 10x minus 15. Kind of sneaking over into my second problem there. And I'm going to simplify even further and just combine like terms. So I have 8x cubed plus 18x squared minus 14x minus 15. And that's my derivative. All right. Let's look here at the trigonomic one. We've got y equals 2 sine x cosine x. Well, y prime is just going to be our first, which here is 2 sine x. So we're going to have 2 sine x times the derivative of our second. The derivative of cosine is negative sine x. Plus, I'm going to write this down there, the second cosine x times the derivative of the first, which is just going to be 2, and the derivative of sine is cosine x. So then, it looks like we're going to have negative 2 sine squared x plus 2 cosine squared x. And you can just leave it like that if you want. If you feel like simplifying it further, you could. You could rewrite this as 2 times cosine squared x minus sine squared x. That's the exact same thing. But that's it. That's basically the product rule in action. All right, so let's go down here and talk about actually the quotient rule. The quotient rule states that the derivative of f of x over g of x is equal to g of x times the derivative of f of x minus f of x times the derivative of g of x over g of x quantity squared. So I think of this as the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. All right, so let's do this one. G of x is equal to 2x cubed plus 4x squared minus 7 over x minus 5. So g prime of x is going to be equal to the top, or the bottom, excuse me, x minus 5 times the derivative of the top. We're going to have 6x squared plus 8x minus the top, 2x cubed plus 4x squared minus 7, times the derivative of the bottom, in this case is just 1, all over the bottom, x minus 5 squared. So that's going to be equal to, we're going to have 6x cubed plus 8x squared minus 30x squared minus 40x minus 2x cubed minus 4x squared plus 7. I had to distribute that negative there. All over x minus 5 quantity squared. So that's going to be equal to 4x cubed. Nope, not a plus sign. 30 minus 8. We're going to have minus 22 x squared. Oh, I had plus the 4. Good. All right. Minus 40x plus 7 all over x minus 5 quantity squared. And actually, I would just leave that. Don't simplify it anymore. Don't bother putting time and effort into it. It's perfect just as it is. So I'll just put a box around that. That's good. So our second example here, y equals the sine of x over 1 plus the cosine of x. Well, y prime is going to be equal to the bottom, 1 plus cosine of x, times the derivative of the top. The derivative of sine is cosine, minus the top, sine of x, times the derivative of the bottom is just going to be negative sine of x, all over 1 plus cosine x quantity squared. So far, so good. So this is equal to, I should put an x there, cosine of x plus cosine squared of x. So negative times negative is a positive, plus sine squared x, right? So all over 1 plus cosine squared, cosine x quantity squared, excuse me. So cosine of x plus sine of x, that's actually just going to be equal to 1, right? We know that from our trig identities, so this is equal to 1. So now I just have 1 plus cosine x over 1 plus cosine x squared, and that simplifies even further to just become 1 over 1 plus cosine of x. And that's our derivative. All right. So we can actually take these product and quotient rules and kind of apply them, I guess kind of in a slightly more general sense, using a table here. So we are asked to calculate the derivative using the values in the table. And you will have problems like this in your assignment, and that's kind of why I included them here. I think they're a lot of fun, and I think they're a good challenge to do. So here we have f times g prime of 2. That's what we're trying to find. Well, this is basically the same as saying we can use the product rule here, right? So we're going to have f of 2 times g prime of 2, our first times the derivative of the second, plus the second, g of 2, times the derivative of the first. Sorry, this should be f prime of 2, right? So f prime of 2. And we actually have these values here in this table. So f of 2 is equal to 8. So this is all equal to 8 times g prime of 2 is negative 1, plus g of 2 is 4, times f prime of 2 is negative 2. So now I have negative 8 plus negative 8, which equals just negative 16. Good? Kind of fun to do? Let's try this. F over g of prime of 2. Well, that we can just use our quotient rule. So we're going to have the bottom, g of 2, times the derivative of the top, f prime of 2, minus the top, f of 2, times the derivative of the bottom, g prime of 2, all over g of 2 squared, the bottom squared. So that's equal to 4 times negative 2 minus 8 times negative 1 all over 4 squared. So it looks like we're going to have negative 8 plus 8 over 4 squared, just going to be 0. I almost wrote 16. All right, let's do 3 and 4, and then we'll kind of wrap this up. We want to find capital F prime of 2, where f of x is equal to x squared times f of x. Well, we're wanting to find the derivative of this here and then calculate it at x equals 2. So we're going to use what looks like our product rule here. So f prime of x is going to be equal to x squared times f prime of x plus f of x times 2x. So now we can actually calculate f prime of 2 is going to be equal to 2 squared times f prime of 2, we already know, is negative 2, plus, we already know this, is 8 times 2 times 2. So here we have 4 times negative 2 plus 8 times 4. So we have negative 8 plus 32, which equals 24. And finally, we'll just do our last one here. One more to go. We want to find g prime of 2, where g of x is equal to g of x quantity squared. Well, g of x is equal to g of x times g of x, right? So we can use this, a product rule again. So g prime of x is equal to the first g of x times the derivative of the second, plus the second times the derivative of the first. Kind of fun to look at there. So this is going to be equal to 4 times negative 1 plus 4 times negative 1, which is equal to negative 4 plus negative 4, which equals negative 8. And that's it. That's the product and quotient rule in action. Hopefully all of that made sense to you. Any questions, go ahead and leave them in the comments in the video, and I will see you in class. Bye!